Good afternoon, students. Today we are going to do the analysis of NEET paper of 2023. Physics, only physics. Right. So let's see how the question paper was. Okay, so these are the sections you can see from 11th and 12th class. For class 11th, we have divided it in three parts: mechanics, heat, and SHM and waves. From mechanics, if you see, there were 7 easy questions, 4 medium level questions, and 1 difficult questions. Okay, so total in section A, there are 2 sections, section A and section B. In section A from mechanics, total questions were 12. Right. If we talk about heat and thermodynamics, total questions were 2. 1 is easy and 1 medium. Okay. SHM and waves, total questions were 1 alone, and that was easy question. If you look at the class 12th portion, electrodynamics, which is actually electricity and magnetism, total questions were 12. 8 easy, 3 medium, 1 difficult. Okay. And then optics, ray optics and wave optics combined, total questions were 2, and both were easy. Modern physics and electronics, in that one, total questions were 6. 5 questions easy, 1 question was medium. Okay, so total questions in section A were 35, 24 easy, 9 medium, and 2 difficult. Okay, let's see further. Section B. Section B, 11th again, mechanics. Mechanics questions were 4, 1 easy, 2 medium, 1 difficult. Okay, heat and thermodynamics, there was no question from it in section B. SHM and waves, 1 question, and that was difficult. Electrodynamics, that is again electricity, magnetism, total questions were 6, 4 easy, 1 medium, and 1 difficult. Okay, optics, 2 questions again, 1 tough, rather 1 easy and 1 tough. Okay, modern and electronics, 2 questions, both were easy. The total easy questions were 8, medium 3, difficult 4. Okay, level of questions. Okay, how it was. Section A, easy were 68.6. Nearly 70% questions were easy. Okay, 26% questions were medium, and 5.7%, nearly 6% questions were difficult in section A. Section B here, 53.3% were easy. Okay, difficult 26.7%, and medium is 20%. So in this one, difficulty has increased as compared to section A, right? Okay, class-wise distribution, how the questions were. From 11th, 40% questions were asked, and from 12th, 60%. Okay, normally also from 12th, there will be an edge, but this time the ratio was 60-40. Let's compare it with last year's question paper. This is last year, the level of difficulty, 60% easy, 34% medium, and 6% difficult questions were there. If we see this year difficult questions are more. Okay, easy are also slightly on the more side, easy also more, difficult also more, so medium has decreased this year. Okay, right. So let's see the question paper now. How is the question paper? So how we are going to solve the question paper? We are going to solve the question paper in order of the chapters which are there in 11th and 12th. So first I'm going to take from errors. Errors and units and dimensions. Okay, there were 2 questions from errors. In both we are going to see first. Right. So see then, the errors in the measurement which arise due to unpredictable fluctuation in temperature and voltage supply are. Okay, unpredictable fluctuations. Now, if the fluctuations are in temperature, we cannot control it. It's not in our hand. Same way fluctuations are happening in the supply, that also we cannot handle or we cannot predict. So what type of errors these are called? These are called random errors. Okay, these are called random errors. Personal errors, that means it should be because of me, I'm doing some mistake. Least count error means it's an instrument error. Okay, least count errors. And third one is instrumental errors. If suppose that there is negative error in that one. So those are instrumental errors. But these errors which are unpredictable and which we have no control on, these are called random errors. So first question's answer will be random errors, easy question. Next one, a metal wire has mass 0.4 plus minus 0.002 gram, radius 0.3 plus minus 0.001 mm, and length 5 plus minus 0.02 centimeter. The maximum possible percentage error in the measurement of density will be. Density, error in density. And density is what actually? Mass by volume. Mass by volume. Okay, and this is a metal wire. Metal wire means it's like a cylinder. So what will be its volume? Pi r square L. So we can write over here m. This is m by pi r square L. Right? This is the formula of density. Now we want percentage error in density. Okay. So I will say that you want what? Delta D by D. And that will be equal to what? It depends on what? D depends on mass, radius, and length. So there will be possible error in the measurement of mass. It is already given how much error we can do. Okay, possible error in measurement of radius, that is also given to us. And possible error in measurement of length, that also is given. So how to write this expression here? We'll say that delta n by m. Okay, plus 2 times delta r by r plus delta L by L. Errors are always added. They're not subtracting. Okay, here power is 2, so 2 delta R by R. Delta L by R. So what are the possible in this one? Possible errors are given 0.002. Let's write here. 0.002 by M, 0.4 plus 2 times delta R. What is it? 0.02 by 5. Sorry, that's the length. That's not radius. The radius is that one. So 2 into 0.01. No, 0.001. Okay. 0.001 by 0.3 plus delta L means 0.02 by 5. Okay, now you want it in possible percentage error. Percentage error means you multiply with 100. It will be easier for us to calculate once we are multiplying it with 100. That means everything with 100? Yes, everything. Multiply everything with 100. Okay, so what's going to happen? It will become a little easy for us. 0.002 into 100 will become 0.2 by 0.4. Plus, okay. Here also 100 will multiply. So 0.001 will become 0.1. 0.1 into 2, 0.2. 0.2 by 0.3. Plus 0.02 into 100 will become 2. 2 by 5. Okay, so it's very easy now. 0.2 by 0.5. Then it's 2 by 4. Actually, it's 0.5. Plus, this is 2 by 3. 2 by 3 means 0.67. So 0.67. And 2 by 5 is 0.4. So 0.5 plus 0.4, 0.9. 0.9 plus 0.67. It's 1.57 something. So our answer is 1.6%. Okay, our answer is 1.6%. So this is the way we'll be calculating error, and this we'll be putting it into moderate side. Okay, one was easy, one was moderate in errors. Okay, let's see next question. This is related to kinematics now. Rather, it is related to vectors. A football player is moving southward and suddenly turns eastward with the same speed to avoid an opponent. The force that acts on the player while running is. Okay, football player is moving southward first and suddenly turns eastward. Okay, so let's make first. Okay, what we have to make? The directions. The directions, if you are making, let's say this shows one direction. Okay, and then the other one also will make. Right. So let's make it over here. So we'll say that this is north. This is north here. This is south. This is east here. And this is west. So what it says is initially it was moving towards south. Just moving towards south. That's fine. Suddenly turns towards east. Suddenly turns towards east. That means it moves in this direction. Suddenly. Okay. With the same speed. Okay, fine. The force that acts on the player while turning is. Now force. Force basically is what? Mass into acceleration. And if we talk in terms of vectors, then we know that force and acceleration will be parallel to each other. Okay. So force direction will be acceleration's direction. And acceleration is v2 minus v1 by delta. So in this one, what is v2? V2 is eastward, this one. So v2, I'm just writing as vi cap. Let's assume that its velocity was v, or rather speed was v. Now it has turned towards eastward, so vi cap. And the southward is v minus j cap. Okay, so this is v2. And this is v1. Let's put it in this one. Let's see what's there. v2 is vi cap minus v minus j cap. Okay, by delta. So now what happened? This minus and this minus became plus. It becomes vi plus vj. Vi cap plus vj cap by delta. So I cap plus j cap now in this direction will be your acceleration. So I cap means like this. This is I cap. And j cap means like this. So when you are adding this and this, the resultant will be in which direction? The resultant will be here. It's northeast. Okay, and you are adding vi plus vj. Vi along east, vj along north. Okay, so resultant will be where? Northeast. Where it is? Along northeast. Okay, so answer is northeast here. This is question related to vectors. A basic, very easy question. Okay, next question. This is related to kinematics, 1D. Vehicle travels half the distance with speed v and the remaining distance with speed 2v. Its average speed is. Very easy question. Average speed means what? Total distance traveled by total time. Total distance by total time. Now he says half of the distance you are traveling with speed v and half with 2v. So let's assume that the total distance is traveling is d. From here to here, the total distance is d. Half of the distance is traveling with v and remaining half with 2v. Fine. So let's put it in this one. Total distance is how much? d. Okay. Now here, in half distance, it's traveling in t1 and half distance is traveling in t2. What is t1 then? Distance by speed. How much is distance traveled here? d by 2. half of the distance is saying. So d by 2. So d by 2v t1, and t2 is d by 2 by 2v. Here is also d by 2 by v, and here is d by 2 by 2v. Let's put it over here. This is d by 2v, and that is d by 4v. Okay. What's going to come? Here, its LCM will come 4v. So let's do that. Its LCM is 4v here. Okay. So it comes 2d, and here comes d. So what is happening? 4v will go to the top by 3d. This is the answer. Okay. So here, total distance is d by total time t1 plus t2. T1 equal to what? This is d by 2 by v, and this is also d by 2. So d by 2 by 2v. Okay. So d by 2v here, d by 4v here. This is the time. Then we are taking LCM here, 4v. This comes 2d, and this is d. So answer is 4v by 3. So here is the answer. Right? And this is kinematics questions. Let's see next. What is it? A bullet from a gun is fired on a rectangular wooden block with velocity u. When bullet travels 24 centimeters through the block along its length horizontally, velocity of bullet becomes u by 3. And then it further penetrates into the block in the same direction before coming to rest exactly at the other end of the block. The total length of the blocks. There is a block here. Okay. There is a block. In the block, one bullet enters with speed u. Okay. Then travels 24 centimeters. So somewhere here up to 24 centimeters. Okay. Here its speed becomes u by 3. And then further, here its speed becomes 0. Okay. Here is u by 3. Then finally it is 0 before coming to rest exactly at the other end of the block. The total length of the block we have to find. Okay. What is going to happen? It's retarding from here to here. Uniform retardation. First, we'll write the equation for this one. Which equation we'll write? Third equation of kinematics. What is that? V square equal to u square plus 2as. Okay. V value given to us. It is u by 3. So right here, u by 3 square plus u square. Acceleration we don't know. But this s we know. It's 24 centimeters. Let it be in centimeter only. There's no problem. Okay. This is u square by 9 minus u square equal to 2a into 24 centimeters. Okay, this is what then? Minus u square minus 9u square minus 8u square by 9. So minus 8u square by 9. And this 24 centimeter also you bring here. That's equal to 2a. Let's assume that this is equation number 1. Right? Now what? Now I have to find how much is the total length. So again, same equation I'll be writing, but initial velocity is u and final velocity is 0. Okay. So let's see. V square equal to u square plus 2ax. X we are finding now. This is 0. This is u square. This is 2a. Now 2a value already have. Okay. 2a value we already have. We can simplify it a little. 8 3 here we can write. So minus u square by 27. That is the value of 2a. So minus u square by 27 into x. Okay. Bring this u square this side. So minus u square equal to minus u square by 27 into x. This minus u square cancel. X value is 27 centimeter. X value is 27 centimeter. So two equations we have to write. One for this 24 centimeter, and then you could have written for this also. Then you would have got this value. Then you would have added in 24 centimeter and found out total length. But what we did here is we applied it over here. Okay, so we directly got 27 centimeter. That means fourth option is correct answer. Okay, here will come fourth option, which is 27 centimeter. Right? Okay, let's move next towards the next question. What is that? So far, all the questions that we are doing, they are related to kinematics. Okay, where we are applying kinematics concepts and formulas. Okay. Previous question, you could have also correlated this with the Newton's laws of motion because force is there in it. Okay. See then, calculate the maximum acceleration of a moving car so that a body lying on the floor of the car remains stationary. The coefficient of static friction between the body and the floor is. Okay, so car is there and it's moving, but there is a body lying on the floor of the car which is at rest. Fine. So let's assume that this is how the car is. Okay, and here is something which is kept on the car. Car is moving with acceleration, but this is at rest. Rest means with respect to car, not with respect to ground. Otherwise, car will slip under it and this will come down, right? So on the car, it is at rest. That means it's moving along the car. Okay. Object is moving with car. Now the question is, who is making it to move? Which force? Which force is making that body to accelerate in the direction of acceleration of the car? And that's friction. So friction is acting on this one. Where friction is acting here? That's friction. Okay. The coefficient of static friction between the body and the floor is 0.15 given. Okay, and it's also given that there's a maximum acceleration. It's the maximum acceleration with which this body is going. That means for this, you require maximum force. Okay, then only you can have maximum acceleration. So that means our force of friction is maximum. Maximum static value means limiting friction. Okay, limiting friction is acting on it. The limiting friction's value is what? Mu mg. Okay, and that is only giving it the acceleration of A. So we can write mass into acceleration equal to mu mg. M and M gets cancelled. Acceleration is coming mu g. And mu is given to you how much? 0.15. So 0.15 into g. Now g, how much we have to take? Is it given? Yes, 10 meter per second square. So into 10. Answer is 1.5. Okay, answer is 1.5. Answer is 1.5. Okay, so this is this question, right? Next, move on, because I can't say which question it is according to our order. Okay, this is section paper and report is F1. Okay, from that I have taken the questions, but I have arranged them like 11th in the order of the chapters, right? Let's move ahead. What is this now? A horizontal bridge is built across a river. A student standing on the bridge throws a small ball vertically upwards with a velocity 4 meters per second. The ball strikes the water after 4 seconds, the height of the bridge above water surface. Okay, now we can say the bridge normally will be like this. Okay, like this will be the bridge, and boy is standing on this one, and he's throwing the ball, and here somewhere is the river or water or whatever. Okay, so he's throwing the ball. What he says is he throws the ball vertically upwards with a velocity of 4, and the ball strikes the water after 4 seconds. So he's throwing the ball with 4 meters per second. That means if I say it's time of ascent used to be u by g. Okay, so time of ascent is u by g, and u is given 4. If I take g10, it's given as 10 only over here. So that means time of ascent is just 4.4 rather. So ball is going like this, and then speed becomes 0 at the top, and then it is falling into the water. So upward time is 0.4 seconds. And total time it has taken is 4 seconds. So 0.4 in going up, then remaining 3.6 seconds. It's time of descent. And what is time of descent formula? Time of free fall. Time of free fall is root 2h by g. So 3.6 actually is root over 2h by g. And h is what we are finding. No, what we are finding actually? Height of bridge above water surface. Okay, this will give us the height of the ball from water surface. This h. Okay, this h. But what question is asking? Question is asking x counts. No problem, we can find it. But let's find h first. Okay, so this is 3.6. I'm squaring it. 3.6 into 3.6 equal to 2h by g. So this becomes 1.8. So h equal to 3.6 into 1.8 into 10. That is 18, because g is given as 10 to us. So how much is this coming? This will be 8. This will be 364.8, I think. Yeah. This is 64.8 meter. What? This. But are we finding that? No. We have to find x value, not h value. Okay. Right. Now what I'll do? Now the question is, you have to find this height from here to here, how much it is, because then I'll be subtracting this from h value. Okay. So what I'll find now? Y. Okay, fine. We'll find y also. With what speed he has thrown? 4 meters per second. Okay. So this y value, I'm just writing as u square by 2g. Maximum height formula, u square by 2g. So this is 4 into 4, that is 16. 16 by 2 into 10. Okay. This is 8. So y is coming 0.8 meter. Okay. Okay. So this is 0.8. Total is 64.8. This is 0.8. So this is how much? 64. So our answer is what? 64 meter. Okay. Our answer is 64 meter. So how will we rate this question? Not very easy. Okay. Not very easy. Moderate, you can say, or slightly on the difficult side. Okay. Next. A bullet is fired from a gun at the speed of 280 meters per second in the direction 30 degrees above the horizontal. The maximum height attained by the bullet is. It's a projectile question. Maximum height he's asking directly. Directly you can write the formula also. Okay. What is the formula for maximum height? U square sine square theta by 2g. So u sine theta whole square. So u is what? 280. Sine 30 whole square by 2 into 9.8. G is 9.8. So 280 into sine 30. Sine 30 means 1 by 2. So 280 into 1 by 2 means 140. Okay. So 140 into 140 by 2 into 9.8. So this is 70 here. Okay. Now then, this is 710 ja, and this is 7.4, 1.4, sorry. This is 1.4, right? 1.4, and this is 100. I think 1000 meter is our answer. Yeah, it's there. 1000 meter is our answer. So simple formula based question, u square sin square theta by h. Okay, let's see further then. The potential energy of a long spring when stretched by 2 centimeters is u. If the spring is stretched by 8 centimeters, potential energy stored in it will be. This is work per energy problem. Okay, this is work per energy. But simple again. He says if you are stretching it by 2 centimeters, your potential energy is u. So I'll say that half k into 2 square is equal to u is given to us. Then if the spring is stretched by 8 centimeters, then okay, half k into 8 square. Then potential energy is what? We are saying u1. Okay, divide it, half cancel, k cancel. This is 4. This is 64 equal to u by u1. This is 16. So u1 equal to 16u. That's our answer. Easy question. Option 3. Okay. This is work per energy problem. And then what we have? This is rotation problem. Actually, question number 1 of that set. Ratio of radius of gyration of a solid sphere of mass m and radius r about its own axis to the radius of gyration of the thin hollow sphere of same mass and radius about its axis. So he's asking radius of gyration. Okay. Radius of gyration is what? Radius of gyration is about which moment of inertia is we take as mk square. Okay, mk square. But he says this mk square is what? The ratio of radius of gyration of solid sphere of mass m and radius r about its own axis. So normally what used to be? It used to be 2 by 5 mr square. So what is radius of gyration here? K is equal to root 2 by 5 r. Okay, this is k1. Let's same way he says radius of gyration of thin hollow sphere. Again, mk2 square equal to 2 by 3 mr square. Moment of inertia of hollow sphere. Same gets cancelled. So k2 is equal to what? Root 2 by 3 r. Now he wants k1 by k2. Now when you do k1 by k2, this root 2, r and r gets cancelled. So our answer will be coming root 3 by root 5. Root 3 by root 5. But in options, root is not there. The root is not there. So possibly bonus questions, bonus marks will be given to you for this question. Okay, bonus marks will be given. But if at all you have to tick it, okay, you should not leave it. So if you have to tick it, you should have ticked question option number 4, which is 3:5, which is actually the ratio of moment of inertias of solid sphere and hollow sphere. Okay, not radius of gyration. These options are given for moment of inertias. Okay, easy question, but let's see how it goes. Right. Again, second question of rotation. The angular acceleration of body moving along the circumference of a circle is. Okay, direction they want. The angular acceleration of a body moving along the circumference of a circle is along the radius towards the center, along the tangent to its position, along the axis of rotation, along the radius away from center. So once we have to understand what type of vector is angular acceleration. It is axial vector. Axial vector means its direction is along the axis of rotation. Always, yes, all axial vectors directions are along axis. No need to see anything along the axis of rotation. Okay, angular acceleration acts along the axis of rotation. That's all. Right. Let's see now this one. The amount of energy required to form a soap bubble of radius 2 centimeters from a soap solution is nearly. Okay, amount of energy required. Surface energy. Surface energy is what? Surface energy is surface tension into change in area. Change in area. You are forming it here. So whatever area you are giving is that is change only. So 4 pi r square because you are making soap bubble. So change in area is 4 pi r square. It's a soap bubble, so that means 2 times surface tension because soap bubble has 2 surfaces. Okay, so put the value then. 2 into 0.03 into 4 pi into r square. What is the radius? Radius is 2 centimeter. So 2 into 10 to the power minus 2 square. Okay, what's the answer? This is 0.06 into 4 pi, and here is 4 square. This is 4 into 10 to the power minus 4. Then this is 6 into 10 to the power minus 2. 4 into 4, 16. 16 pi into 10 to the power minus 4. 96 pi into 10 to the power minus 6. Okay, but here we want answer, direct answer. Approximate answer can be found in 96 into 3.14. Okay, into 10 to the power minus 6. Nearly, we can say 300 into 10 to the power minus 6. Okay, so 300, 96 into, that means 100 into 3. So 300 into 10 to the power minus 6. So that means approximately 3 into 10 to the power minus 4. Check anything is there like that. Yeah. Okay, so 3.01 into 10 to the power minus 4 joule, we can write its answer. Okay, let's see next. Venturi meter, fluid mechanics, fluid dynamics. Venturi meter works on Bernoulli's principle. Principle of parallel axis rotation, principle of perpendicular axis rotation, Huygens principle. Okay, so Huygens principle means what? Huygens principle, that's wave optics. Only one thing is related to fluids, and that is Bernoulli. So very easy question. Okay, next. Let a wire be suspended from the ceiling, rigid support, and stretched by a weight W attached at its free end. The longitudinal stress at any point of cross-section area of the wire is. What is longitudinal stress? Force applied by area of cross-section. So what force are we applying? This. There is a wire like this. Okay, and here you are suspended one weight W, and here area, this cross-section area is A. So what is longitudinal stress? Stress is force by area. What is force? W, cross-section area A. That's all. So our answer is simple. Okay. Next one. Okay. The xt graph of a particle performing simple harmonic motion. It's a question of simple harmonic motion. Shown in the figure, the acceleration of the particle at t equal to 2 seconds. So at t equal to 2 seconds here, you can see that particle is at the top. Particle is at the top. Okay. Particle is here. Here. Okay. So what will be acceleration? Acceleration of particle doing SHM is minus omega square into displacement. Now displacement here is maximum. How much is displacement? 1. So minus omega square into 1 meter. Now omega is what? Omega is 2 pi by t. So minus 2 pi by t. Now you can see the time period. This is time period, 8 seconds. So by 8 whole square. So this is 4. So it's pi by 4 whole square. That means pi square by 16. Minus pi square by 16. Where it is? Yeah. Minus pi square by 16 is downwards. Acceleration is downwards. So minus pi square by 16 is the answer. Okay. That's a SHM question. Then what we have? The ratio of frequencies of fundamental harmonics produced by an open pipe to that of a closed pipe having the same frequency. This is related to sound. Okay. Now frequencies of fundamental frequencies of open organ pipe and closed organ pipe. So fundamental frequencies for open organ pipe formula is NV by 12. So fundamental means N is 1. Okay. So for open organ pipe, so you'll say V by 2L. Length is given same. For closed pipe, what is the fundamental frequency? V by 4L. Okay. Then what they want? The ratio of frequency of fundamental harmonic produced by open to close. Open to close. Okay. L and L gets cancelled. V and V gets cancelled. So what we are getting? 4 by 2. That means 2 is to 1. Okay. 2 is to 1 is our answer. Open organ pipe, V by 12. Closed organ pipe, V by 4. 2 is to 1. Okay. Easy question. Let's go ahead. The temperature of a gas is minus 50 degrees centigrade. To what temperature the gas should be heated so that the RMS speed increases by 3 times? RMS increases by 3 times. Then how much it has become? It's not that RMS speed become 3 times. He didn't say become 3 times. Okay. RMS speed is increased by 3 times. So how much RMS speed has become? 4 times. Okay. So first, V is equal to, what is the formula? Root over 3RT by M. This is the formula. Time, not time. Temperature is given minus 50. Minus 50 means what? Minus 50 plus 273 Kelvin. Okay. So 223 Kelvin here. So V is equal to 3R into 223 by M. Now he says when it becomes 4 times. We don't know. Let's see, 4V equal to root 3RT1 by M. So in place of V, I can write this. So put it over here. 3R into 223 by M equal to 3R T1 by M. 3RM gets cancelled. Now what to do? Square it. What else we can do? So 16 into 223 equal to T1. So what is coming here? This is 8, 6, and 3, 5. Okay, 3568 Kelvin. But like this, no answer is there. So let's try in degree centigrade. This is in Kelvin. Okay. So 3568. From here, what we can do? 273 shall we subtract? So this is 5. Okay. Then here 16 minus 7, that is 9. This is 4 minus 2, that's 2. 3295. Yes, answer is there. The first one is our answer. Okay. So 3295 degrees centigrade. And what 3568 was? Kelvin. So Kelvin we converted into degree centigrade. We got 3295. Okay. This is the question. You can put it in medium or tough side. Why tough side? Because this we need to understand. At the time, at the pressure time, you will be making it just 3 and you can do it. You will understand that it increased to 3 times. It was increased by 3 joules. Okay. Right, thermodynamics question. A Carnot engine has an efficiency 50% when its source is at temperature 327 degrees centigrade. The temperature of the sink is. Simple formula based problem. Okay. Efficiency is equal to 1 minus T1 by T2. 1 minus T2 by T1. 1 minus T2 by T. Now, how much is efficiency given? 50%. That means 1 by 2. So 1 by 2 minus 1. That is minus 1 by 2 equal to minus T2 by T2. This is getting cancelled. What's given? Source temperature is given 327. Convert this in Kelvin first. So 327 plus 273. That is 600 Kelvin. Okay, so 600 Kelvin. 1 by 2 equal to T2 by 600. So T2 equal to 300 Kelvin. Let's see what's answer given in Kelvin. No, it's given in degree centigrade. So minus 273, 300 minus 273 is 27 degrees centigrade. Our answer is this. Okay, our answer is 27 degree centigrade. Okay. Right, let's see further. Two bodies of mass, this is gravitation question. Two bodies of mass m and 9m are placed at a distance r. The gravitational potential on the line joining the bodies where the gravitation field equals 0 will be. Okay. So here is mass m and here is mass 9m. Separation between them is given r. And he's saying that find the potential at a place where gravitation field is 0. So first we have to find the position where gravitation field is 0. So let's assume it's somewhere here. This is the point. So wherever gravitation field is 0, it means gravitation field of m must be equal to gravitation field of 9m. Both are having the gravitation fields of attraction force. So m's field will be in this direction, gravitation field due to m, and 9m's field will be in this direction, that is gravitation field of 9m. Okay, so I'm equating it. Okay, g m by this distance is x. So gm by x square. Then this distance will become r minus x. So g into 9m by r minus x whole square. G and m cancel. Cross multiply. 9x square equal to r minus x whole square. Take square root. 3x equal to r minus x. This is 4x equal to r. That means x equal to r by 4. Okay, one part is done. This is r by 4. This will be 3r by 4. Now we have to find potential over here. Okay, so it's potential minus gm by r by 4 plus minus g 9m by 3r by 4. Okay, now this 3, with this 3, I can cancel this, becomes 3. So what we have, minus gm by r by 4 minus 3gm by r by 4. So it becomes minus 4gm by r by 4. So r is over here, 4 you take at the top. So potential is minus 16 gm by r. We have to check whether that is there or not. Yes, it is there. Second option. So minus 16 gm by r is the answer of this question of potential. Okay, minus 16 gm by r. All right, let's see next question of gravitation. A satellite is orbiting just above the surface of the Earth with a period t. This is a time period. If d is the density of the Earth and g is the universal constant of gravitation, the quantity 3 pi by gd represents. Okay, right? G is universal constant of gravitation and d is the density of the Earth. And time period is also given. So first thing is we are going to write what is time period. Time period formula is 2 pi r to the power 3 by 2 by root gn. T square is proportional to r cube, we know already, okay? But here, this is also required to write because he's talking about density. Okay, and he's saying 3 pi by gd. Let's see what that is. So T value is this, okay? 3 pi by gd is what? 3 pi by gd. So here is 3 pi by g. Density I'm writing, that is mass by volume. So mass by 4 by 3 pi r cube. So mass by 4 by 3 pi r. Okay? Mass by volume. So volume will go at the top. And I'm writing volume here. That is 4 by 3 pi r cube. Okay, what we can do over here? 3 cancelled. Okay, so I have here 4 pi square r cube by gm. Okay, you see over here, here is r to the power 3 by 2 and gm. Why not square it once? T square is equal to 4 pi square r cube by gm. Is it the same thing? Yeah, here is also 4 pi square is there. Pi into pi. This is the same. So 3 pi by gd actually is equal to t square. Equal to what? It's equal to t square. So 3 pi by gd represents t square. Right? And that's how it is. This was a new thing. So slightly unknown territory. Okay, not direct question. So we can put that into kind of a tricky thing, right? Let's see next now. Okay, electrostatics. Okay, Gauss law. If E dot ds is equal to 0, If E dot ds is equal to 0 means flux 0, right? Okay. So if flux is 0 over a surface, then the magnitude of electric field on the surface is constant. Magnitude of electric field on the surface is constant. If on the surface it was constant, then how flux would have been 0, right? Not possible. All the charges must necessarily be inside the surface. If the charges are inside the surface, then how can flux be 0? Because Gauss law says flux is equal to charge inside by epsilon naught. So not possible. The electric field inside the surface is necessarily uniform. No. The number of flux lines entering the surface must be equal to the number of flux lines leaving it. Absolutely. If this is there, then we can say that the flux is 0. Net flux is 0. Because when flux comes inside, it becomes negative. When flux goes outside, it becomes positive. When you add it, total, if they are same, then the total flux is equal to 0. That's what the question is saying. So if flux is 0, it means number of lines coming inside equal to number of lines going outside when the surface is same. Okay. Perfect. Okay. Then what? An electric dipole is placed at an angle of 30 degrees with the electric field of intensity. It experiences the torque equal to 4 Newton meter. Calculate the magnitude of charge on the dipole if the dipole length is 2 centimeters. Okay. What is torque? Magnitude of torque is P E sine theta. What is P here? P is dipole moment, E is electric field. So here electric field is given. He says dipole is making angle 30 degrees with electric field. So fine. So this is P. Torque is given 4 Newton meter. P we don't know. This is 2 into 10 to the power 5. And this is sine 30. That is half. Okay. So dipole moment is what? This 10 to the power 5 comes here. It is 4 into 10 to the power minus 5. Right? Okay. Now what is dipole moment? Charge into length of dipole. Is length of dipole given? Dipole length is 2 centimeters. Okay. So Q into 2 into 10 to the power minus 2 equal to 4 into 10 to the power minus 5. So this is 2. Q is 2 into 10. This is minus 5. Yeah. 2 into 10 to the power minus 3. That means 2 millicoulomb. Here it is. Answer is 2 millicoulomb. Okay. Perfect. What next? Okay. An electric dipole is placed as shown in the figure. The electric potential in 10 square volt at point P due to the dipole. Epsilon naught is permittivity. Okay. So you want to find at this point. Okay. What potential? Potential along the axis. But in this one thing we have to see is the length of dipole is not small. This R, normally we take this as R. R is comparable to L, the length. So I cannot write potential at P as Kp by R square. It is not. The normal formula that we use, Kp by R square, that is not correct. Then what we have to do? Potential at P is actually Kp by R square minus L square. L square is what? This is L. This 3 centimeter is L. Okay. 3 centimeter actually is L. This is L. Now we can do that. Let's see what's coming. The potential at P, K value 9 into 10 to the power 9. Then what? Dipole moment also we have to write. Right? Okay, in terms of Q only, so no issues. This is Q into total length is 6 centimeter. So 6 into 10 to the power minus 2 by R. R is 5 centimeter. So 5 into 10 to the power minus 2 whole square minus 3 into 10 to the power minus 2 whole square. Okay, and this K also we don't have to write because answer is given in terms of K only. So put K. Okay, so here is 6 into 10 to the power minus 2 and here is 25 into 10 to the power minus 4 minus 9 into 10 to the power minus 4. So 25 minus 9 is 16. So KQ 6 into 10 to the power minus 2 by 16 into 10 to the power minus 4. So this is 3 and this is 8. So our answer is 3KQ by 8 into 10 to the power 2 volt. Okay, anyhow he's saying 10 to the power 2 volt is there. So our answer is 3 by 8 KQ. This is it. So fourth option. Okay. 3 by 8 KQ. Next one. Very easy diagram. What we have to find? Equivalent capacitance of the system shown in the following circuit. These two are parallel. 3 plus 3, 6. And then 6 is in series with 3 ohm, or rather 3 farad. Okay. So 3 and 6. They are in series. So what is the net? 2. Because C net will be 3 into 6 by 3 plus 6. That is 18 by 9. That is 2 microfarad. So answer is 2 microfarad here. Right. Next. Resistance of a carbon resistor determined from color codes is 22,000 plus minus 5%. The color of the third band is. Now, carbon coding, we have very good rhyme is there or poem is there that we remember for this one, right? That B.B. Roy of Great Britain had a very good wife. Correct or not? B.B. Roy of Great Britain. The very good wife. G and W. Okay. Numbers are given to that 0, 1, 2, 3, 4. 5, 6, 7. Like this numbers are given. Okay. So we have to find third. So this one represents first, this one represents second. Then third is what? 0? No. This is not written like this. This is written in this way. 22 into 10 to the power 3 plus or minus 5. You see, this question needs to be written in this way. Okay. So this is first band, this is second band, and this is the third band. The power of 10. Understood that? This is the third one. What is third one here then? See. Third band is orange. So our answer here is orange. That's all. Whoever remembers this, whoever remembers how to write this in proper way, we got the answer. This is not the way to write it. This is the way to write it. First band, second band, third band. And after that, this is percent. But it is not used over here, so there's no point in saying. But this rhyme is necessary. You should know this rhyme. Okay? And it goes up to 9. All right? Okay. Next. If the galvanometer G does not show any deflection in the circuit shown, the value of R is given by. This is not showing any deflection to galvanometer. That means no current is going in this. Why no current goes? If no current is going in circuit or any branch, it means there is no potential difference. That's why. So if I assume that potential here is 0 and potential here is 2 volt, that means here also 2 volt and here 0 volt. Same way here also 0 volt. Then since we are saying no current in this one, that means here is also 2 volt. Definitely. Right? So across this is 2 volt. And here also this is 0. So this is also 0. So here is 10. So potential difference across this 400 ohm is what? 8 volt. So current is how much? Current in this one? Potential difference 8. And resistance is 400. Okay. So that means 1 by 50 ampere. 1 by 50 ampere is here. Correct? No doubt about that. What is the question asking? Value of R they are asking. So this 1 by 50 current which is there, nothing is going this side. Means same 1 by 50 is going here also. Right? And here how much is potential difference? 2. So we'll write 2 equal to what? I into R. So 2 equal to 1 by 50 into R. So R is what? 100 ohm. That's it. R is 100 ohm. That's our answer. Okay. Here is our 100 ohm. As simple as that. Right? Okay. Let's go to the next one then. All right. The magnitude and direction of the current in the following circuit. Magnitude and direction. All right. Let's see what we can do here. And directly we can apply Kirchhoff's law. Okay. How to move? Let's say we are going to move like this. Like this here. This is the loop. Okay. So we are starting from point E. So point E we are going. First we are going from higher potential to lower potential for 5 volt battery. So higher to lower means -5. Then we are going in 1 ohm. In the direction of current. Yes, we have taken direction of current like this. So -1I. Then here also direction of current. So -7I. Here also direction of current. So -2I. Then there is a battery. You are moving from lower potential to higher potential. So +10 equal to 0. So what we have then? -I, -7I, -8I, and -2I, -10I. Okay, so -10I. Then -5 plus 10. So +5. So now -10I equal to -5. So I equal to 5 by 10. That means 1 by 2 ampere. That's what the question is asking us. What is the current? So 1 by 2. And its direction is from A to B. Yes. Only one option is there, 0.5. So no need to check the direction also. Okay. 0.5 ampere from A to B through B. Perfect. Next. 10 resistors, each of resistance R are connected in series to a battery of EMF E and negligible internal resistance. Then those are connected in parallel to the same battery. The current is increased n times. The value of n is. Big question. You need to understand it. 10 resistors are there. Of resistance are connected in series with battery of EMF E. So I value is E by 10R because they are connected in series. Very simple. Then same 10 are connected in parallel with the same battery. Okay. Then what is the current? So same battery means E. Now this time resistance will be what? R by 10. So R by 10 means here. Then what? The current is increased n times. Okay. So they are saying I1 is equal to Ni. So what is N? Okay, let's put it. I1 is 10E by R. And this is n times E by 10R. E and E cancel, R and R cancel. N is 100. So N is 100. Okay. N is 100. Fine. Let's move ahead then. What is this? The resistance of a platinum wire at 0 degrees centigrade is 2 ohm and 6.8 ohm at 80. The temperature coefficient of resistance of wire. Direct formula base, right? RT equal to R dot into 1 plus alpha delta T. This is how resistance changes with temperature. So what is RT given? 6.8 ohm. Put it here. What is R0 given? 2 ohm. alpha is asking, and temperature difference is how much? 80 degrees centigrade. So here is 80. This is 3.4. 3.4 minus 1 is 2.4. 2.4 by 80 is alpha value. What's coming? So this point we'll remove and place it over here. This is 83 joule, and this is 800 joule. So 3 into 10 to the power minus 2 per degree centigrade. Second option is correct answer. Okay, easy question. Next, the net magnetic flux through any closed surface. Net magnetic flux through any closed surface, right? So closed surface is there. Through closed surface, the flux will come and it will go. So net magnetic flux through any closed surface will be how much? 0. Because it's not like the Gaussian surface. If the charge is inside, there will be electric flux will be there, Q in by epsilon naught. This is magnetic flux. Okay, so it will be because of the external medium, because of the external thing. So magnetic field is coming and going from a 3-dimensional surface. So answer will be 0. Okay. Next, very long conducting wire is bent in semicircular shape from A to B as shown in figure. The magnetic field at point P for steady current configuration is given by. So now you want to find magnetic field at point P. So there are 3 segments of the wire which are carrying current in different ways. So we have to find magnetic field because of all. But first of all, let's see the direction, because magnetic field is a vector quantity. Okay. So let's talk about the direction first. So because of this section of wire, you want to find magnetic field at P. So what we do is we'll put our thumb in the direction of the current. So it's like this. Okay. Where you want the magnetic field at point P. Okay. So open your arm, or rather open your palm. Okay. And it should point towards point P. And then the palm gives you the direction of magnetic field. So because of this, magnetic field is inside. Okay. Because of this now, again same way, put the thumb in the direction of current. And then you see where is the palm. Palm is again inside. So because of this wire also, it's inside. Okay. Now because of this semicircular section, current is downwards and point P is there. So my palm is outside. Okay. So because of the circular section, magnetic field is outside. That means subtraction is there. Okay. So either answer will be this or that. This mu naught I by 4r I don't think is possible. Let's see. So first of all, because of this is infinite section of the wire. So what will be magnetic field due to that? Mu naught I by 4 pi d sin alpha plus sin beta normally we write. But if I'm dropping a perpendicular on this one like this, okay, if we are dropping a perpendicular like this at that point, okay, and we join this one, we can say this is alpha, and on that side beta is 0. Same for this also. Okay. So magnetic field will be mu naught I by 4 pi d, right? Okay, because of both wires, mu naught I by 4 pi r. This is inside. Okay. Now plus, because of this semicircular section, mu naught I by 4r. Mu naught I by 4r. Where? Outside. So mu naught I by 4r we can take common. Mu naught I by 4r is common. Then what we have? 1 by pi. Okay. 1 by pi minus 1. Now we know that 1 by pi is less and 1 is more. So it will be outside. Okay. So what will be the answer? Correct only, no? Everything. Because 1 mu naught I by 4r taken, 1 minus 2 by pi is 1. Have we done anything wrong? Correct. 1 by 1 minus 2 by pi. Okay, because this was because of 2 wires. All right. Yes. So 2 by pi minus 1. So where is this direction? Where is the direction? We can see that this is more than this one. Okay, because this pi is here. Because of the pi. Okay, here denominator is 12. Here denominator is just 4. So this is bigger than this. So direction will be out of the page. So out of the page means, okay, the option is correct. Let's see further. A wire carrying a current along the positive x-axis has length L. It is kept in a magnetic field B equal to 2I plus 3J minus 4K, the magnitude of the magnetic force. Now, magnitude of the force. Now, what is force formula? This is IDL cross B. Okay. He's asking magnitude only, so not an issue. But since the things are given in vector form, first we will do the cross product. So what it is? I is there, L is there, and direction is positive x-axis. Okay. So I into L into I cap cross 2I cap plus 3J cap minus 4K. So I cross I is gone. So then what we have? 3IL, I cross J means K, then plus 4IL, I cross K. I cross K normally is minus J, but here minus is also there. So minus into minus become plus. So K cap plus J cap. Now they are perpendicular to each other. Okay, perpendicular to each other. So we can add them. So what will come? Magnitude only we want, right? So magnitude of F is going to be, one is along j cap, one is along k cap. Let's assume that this is k cap. So its magnitude is 3. This is j cap. Its magnitude is 4. Okay. So resultant will be here. According to parallelogram law, what it is? This is 90 degree. Then this will be 3 square plus 4 square. That means 5. So its answer will be 5IL. Answer is this. Okay. Answer is 5IL. Next one. The magnetic energy stored in an inductor of inductance 4 microhenry carrying a current of 2 ampere. Simple formula based question. Energy is half L I square. What is L given? Inductance 4 microhenry. Okay. Current 2 ampere. So 2 square. This and this gets cancelled. So it's coming 8 into 10 to the power minus 6. I think this should be the answer. Yeah, 8 microjoule. Okay. Fine. Let's move ahead. In a series LCR circuit, the inductance L is 10 millihenry, capacitance is 1 microfarad, and resistance is 100 ohm. The frequency at which resonance occurs. Direct formula based question is there, but calculation is involved in that. Frequency, resonance frequency is what? 1 by 2 pi root LC. Okay, what you'll do is first root LC will find. What is root LC? Okay, L is what? Where is L? 10 millihenry. So 10 into 10 to the power minus 3 into capacitance 1 microfarad, 1 into 10 to the power minus 6. Okay, so this is actually 10 to the power minus 9 into 10, so 10 to the power minus 8. So root LC is coming 10 to the power minus 4. Put it over here. This is 10 to the power minus 4. It will go at the top. So 10,000 by 2 pi. And this becomes 5,000. Okay, how it's given in terms of this. Okay, so 5,000 by 22 into 7. That way we should do. So this is 11 and this is 25,000. Okay, what else we can do? 2,500 by 11 into 7. Approximate we can do. This is 2. There's 3 here. Then again 2, 8. It will be 7. Approximate. Okay. So this is 9. It will be 4, 8. Something like this. 1589 hertz. Because it's frequency. 1589 hertz means where we are 1.589 kilohertz. Okay. No, not this one. This one. 1589 hertz. That means 1.589 kilohertz. Okay, so we can say 1.59 kilohertz is our answer. C option. Okay. Then 43rd question. 12 volt 60 watt lamp is connected to the secondary of a step down transformer whose primary is connected to AC mains of 220 volt. Assuming that the transformer to be ideal, what is the current in the primary winding? Okay. He says 12 volt 16 watt lamp is connected to the secondary. That means power obtained in secondary is 60 watt. And remember that it's ideal transformer, so power input and power output will be equal. Okay, power input is equal to power output, and power output you already have given 60 watt. Power input, he says primary is connected to 220 volt mains. 220 volt main supply. Okay, so we are writing I into 220. So I is what? 60 by 220. Okay, 3 by 11. 3 by 11 means it's less than 0.3. Less than 0.3 means 0.27 ampere. 0.27 ampere. That will be our answer. Okay. Let's move ahead. The net impedance of circuit. Net impedance. Again, it's slightly lengthy problem. Impedance means what? Because there is L also, C also, R also. Net impedance means XL minus XC whole square plus R square. R is given directly. XL is what? XL is omega L. Omega is what? 2 pi into frequency. Frequency is given 50 hertz. So this is 2 into 50, that is 100 pi into L value. 50 by pi millihenry. 50 by pi into 10 to the power minus 3. This is cancelled. So 5,000 into 10 to the power minus 3. That means 5 ohm. XL is 5 ohm. Now XC. What is XC? 1 by omega C. That means 1 by 2 pi F into C. That means 1 by 100 pi into C. C is what? 10 cube. That means 1000 by pi into microfarad. That means 10 to the power minus 6. This is cancelled. This is 10 to the power 5 into 10 to the power minus 6. That means 1 by 10 to the power minus 1. It will go up. It will be 10. So XC is 10 ohm. Okay, now we can solve it. So Z value, XL5, XC10, square. plus r square, which is also 10. So this is what 5. 5 square means 25. This is 100. This is 125. 125 means 5 root 5. This will be our answer. B option is 5 root 5. Okay, so this was the question of AC, alternating current. Then, in a plane electromagnetic wave traveling in free space, the electric field component oscillates sinusoidally at a frequency of 2 into 10 to the power 10 hertz and amplitude 48 volt per meter. Then the amplitude of oscillating magnetic field is, oh, very easy that is. We know that C is equal to E naught by B naught. B naught he's asking. That will be E naught by C. What is E naught? 48 given. And C is what? 3 into 10 to the power 8. This is 16. Answer is 16 into 10 to the power minus 8 Tesla. 1.6 into 10 to the power minus 7 Tesla. Okay. So this is our answer. Right. Next. An AC source is connected to a capacitor C due to decrease in its operating frequency. In AC source, whenever we talk about capacitance, we talk about capacitive reactance, XC, which is 1 by omega C. Now let's see the question. An AC source is connected to a capacitor C due to decrease in its operating frequency. Frequency decreases means omega decreases. And if omega is decreasing, it means capacitive reactance increases. XC increases. So if capacitive reactance increases, means impedance is going to increase. If impedance increases, then what will happen? Current will decrease. Where it is? Displacement current increases, wrong. Displacement current decreases, correct. Capacitive reactance remains constant, wrong. Capacitive reactance decreases, wrong. It is increasing. So only correct is second option. Displacement current decreases, right? Okay, next. Light travels a distance x in time t1 in air. In air, it travels with speed c. Remember that. Okay. And 10x in time t2 in another denser medium. What is the critical angle for this speed? Okay. So critical angle basically means what? If the light moves from denser medium, let's say its coefficient of refractive index is medium. When light moves from denser to rarer medium in such a way that refracted ray makes 90 degree with the normal, then angle of incidence is called critical. Okay. So if you apply Snell's law, we can write mu sine c equal to air means 1 sine 90. Okay. So that means sine c equal to 1 by mu. The first thing. Related to critical. Now let's talk about what this is saying. He's saying that in air, it travels x distance in time t1. So in air, what is the speed? C. C is the speed. And this C is different than this C. Okay, this is critical and this is speed of light. So speed of light in air, it's traveling x distance in time t1. Fine. Okay, then it says that, and 10x in time t2 in another denser medium. Okay, so what is that speed in another medium? V, and it is traveling 10x in time t2. Now this V is what basically? V is C by mu. Speed of light by refractive index of that medium, which we have considered mu here. So C by mu equal to 10x by t2. Now C value is x by t1, put it over here. So x by mu t1 equal to 10x by t2. X gets cancelled. Okay, mu value I'm getting. That mu only we have to find. So what we are getting from there, let's do it here. Okay, this t2 here. So t2 by 10 t1 equal to mu. t2 by 10 t1 equal to mu. Okay, that mu I'm going to put it over here. So sine c equal to 1 by mu. Okay, so 1 by, what is that? T2 by 10 T1. So C equal to what? Sine inverse 10 T1 by T2. Sine inverse 10 T1 by T2. Okay. Tricky question. We can put it into the difficult one also. Right? Okay. 48. Two thin lenses are of same focal length f, but one is convex and other one is concave. When they are placed in contact with each other, the equivalent focal length of the combination. What is equivalent focal length actually when you are putting two in contact? That is 1 by f1 plus 1 by f2. Let's put it like this. Now he says both are of the same focal length. So 1 by f plus 1 by minus f, because concave focal length we take negative. So 1 by f minus 1 by f becomes 0. So 1 by f value is 0. That means f value is 1 by 0. That means infinity. Sorry. That means infinite. Focal length of combination is infinite. Power is 0. Okay. Right. One more ray of X question. Again, combination of lens only. In the figure shown here, what is the equivalent focal length of the combination of lenses? How many lenses are there? 3 lenses are there. Okay. There are 3 lenses. This is one water lens. This is also water lens. And this is glass lens. So 3 lenses are there. But I can see there are 2 are similar lenses. Here also 1.6 is the mu. Here also 1.6. Here also radius is 20. Here also radius is 20. So this length and this length are identical. So what we can do, when we are writing 1 by f equal to 1 by f1 plus 1 by f2 plus 1 by f3, instead of 1 by f3, I am writing as 1 by f1 only, because these two water lengths are exactly similar. So now it becomes 2 by f1 plus 1 by f. Let's put the value, okay? 2. Now, water length, focal length, I am writing with the length maker's formula. Mu minus 1. So 1.6 minus 1. 1 by r1. Now, r1 is this flat surface, that means infinity. 1 by r1 minus 1 by r2. This is r2 for that. Okay, and its center of curvature is this side. Focal length also that side. So minus. Okay, so minus of minus, that means plus 1 by 20. Plus now, equiconvex lengths. What is that? 1.5 minus 1 into 1 by r plus 1 by r. 1 by r1 minus 1 by r2. Okay, so 1 by r1. So, I think I have done something wrong in this one. Okay, let me write it again. Okay, so 2 into 1.6 minus 1. 1 by r1. 1 by r1 is this. So that is 1 by infinity. Minus, this is the second side. So second side is center of curvature there, focal length is that side. So it should be minus 1. And that was the mistake I committed. Okay. Then here 1.5 minus 1. 1 by r1. Right side. So 1 by 20 minus 1 by 20. Okay. So 2 by 20. What we have? This is 2 into 0.6, that is 1.2 minus 1.2 by 20. 1.6, no, 1.6, 0.6 into 2, 1.2, 1.2 into minus 1 by 20, like this, plus 0.5 into 2, 1, so 1 by 20. We are getting here minus 0.2 by 20. This you can put it over here, it's coming minus 1 by 100. Let's check. Yes, it is there. So focal length is minus 100 centimeter. Focal length is minus 100 centimeter. Okay, that's the focal length of combination. So sign conventions are very, very important. We need to be careful about that. Okay. For Young's double slit experiment, two statements are given below. Statement 1, if screen is moved from the planes of slit, angular separation of the fringes remain constant. No. Angular separation, theta, is actually lambda by d. Lambda is wavelength and d is separation between the slits. So if screen is moved from the planes of slits, angular separation of the fringes remains constant. That's correct. If screen is moved, there is no problem with theta, because theta depends on wavelength and slit separation, not how far is the screen. Here you are taking what? Screen you are taking away. So no problem. That's correct. Statement 2, if the monochromatic source is replaced by another monochromatic source, that means you are going to change the wavelength. Of larger wavelength, the angular separation of fringes decreases. No. If lambda is going to increase, theta is also going to increase. So separation is going to increase, not decrease, as this is saying. So which option? This is wrong and this is correct. The first option is correct, second option is wrong. Which one is there? Okay, angular separation is divided by is given by angular width, which is equal to lambda by d. So if lambda you change, separation will be changing. If small d, slit separation if you are changing, then also fringe separation will change. Okay. Next, okay, there is photoelectric effect. The work function of cesium, potassium, and sodium are 2.14, 2.3, and 2.75 eV respectively if incident electromagnetic radiation has an incident energy of 2.2 eV. Which of these photosensitive surface may emit photoelectrons? Now, work function means what? Minimum energy is required to emit electron. Minimum energy required. Here is 2.3, here 2.7, here is 2.14. How much is coming? 2.2. Okay. How much minimum required here? 2.30. How much minimum required? 2.7. So obviously from here nothing is coming out. From here nothing is coming out. From here definitely possible, because here its minimum energy requirement is less than what energy is coming. So cesium only possible. The remaining all not possible. Right. Then in hydrogen spectrum, the shortest wavelength in the Balmer series is lambda. The shortest wavelength in the bracket series. Wavelength formula is what? 1 by lambda equal to r by 1 minus 1 by n1 square minus 1 by n2 square. So when we say shortest wavelength means when the electron is going to jump from infinity to the base. What is the base here? Balmer series. Balmer series means n equal to 2. Okay. So 1 by lambda equal to r to 1 by 2 square, because other is infinity. So 1 by lambda equal to what? R by 4. Then what are you saying? The shortest wavelength in the bracket. Lyman, Balmer, Paschen bracket. Bracket means its base is n equal to 4. So 1 by lambda 1 equal to r into 1 by 4 square minus 1 by n. So what we are getting? 1 by lambda 1 equal to r by 16. Okay. So what we can do from here, r value I am going to get. R value is 4 by lambda. I'm going to put it over here. 1 by lambda equal to r value 4 by lambda into 16. So this is 4. So lambda 1 actually is equal to 4 lambda. Okay. No, my answer is this. Okay, understood that? The shortest wavelength, whenever they say shortest wavelength, that means you have to jump from infinity to the base of that particular series. The radius of the innermost orbit of hydrogen atom is 5.3 into 10 to the power minus 10, 0.53 angstrom. What is the radius of the third allowed orbit? Third allowed orbit is 0.53 angstrom into n square by z. Hydrogen, so z is 1. Third allowed orbit, that means 3 square. So 0.53 angstrom into 3 square by 1. So 9 into 0.53 angstrom. What will come? 9 into 0.53, 4.5 something. So 4 point something angstrom. 4 point something angstrom is this. Okay, atomic physics question. Yes, students, so let's see how to do this one. The minimum wavelength of X-rays produced by an electron accelerated through a potential difference of V volts produced proportional to. So what we can say is if entire energy that we have given into electron converts into energy, then what will be corresponding to wavelength? And then only it will be the minimum wavelength, no, when the energy is maximum, right? So we all know that if we talk about the energy is equal to hc by lambda. So lambda we can say is equal to hc by E. Now maximum energy is what? He says that electron is accelerated by potential difference of V, and energy is EV, Q delta V actually, right? So here delta V is V. So we can see that lambda is actually inversely proportional to V. So here answer is 1. Okay, then next one. The half-life of radioactive substance is 20 minutes. In how much time the activity of substance dropped to 1/16th of its initial value? So for half-life, we have a formula which says n equal to n naught by 2 to the power n. This is initial activity, final activity. Okay, and this is number of half-lives. Not n. N becomes same here, right? Not this way. We write in this way. N equal to n naught by 2 to the power n. So small n is what? Number of half-lives. So he says n has become 1/16. So this is n naught by 16 equal to n naught by 2 to the power n. This gets cancelled. So we have 2 to the power n equal to 16. That means 2 to the power n equal to 2 to the power 4. That means n equal to 4. That means 4 half-lives. Number of half-lives are 4. He says half-life is 20 minutes. So 4 half-life means 80 minutes. So our answer will be 80 minutes. Okay. Then, okay, statement is there. What is that? Photovoltaic device can convert optical radiation into electricity. Perfect. Perfect. Okay. Photovoltaic cell converts optical radiation into electricity. Solar cell. Zener diode is designed to operate under reverse bias in breakdown region. That is also correct. Both are correct actually. So which one? Both statement 1 and 2 incorrect? No. Statement 1 is correct. Statement 2 is no. Statement 1 is incorrect? No. Both statement 1 and 2 are correct. That is fourth option. Fourth is correct option. Let's go to the next. A full wave rectifier circuit consists of 2 p-n junction diodes, a center tap transformer, capacitor, and a load resistor. Which of these components remove the AC ripples from the rectified output? What is AC ripples meaning? AC basically is like this, and rectifier converts it into this. But we want it to have almost constant value, just like DC we have. We don't want it like this, that much of variation. So which instrument at the moment written over this one, which can change it, or rather which can reduce it? Transformer? No. P-n junction diode? No. Capacitor. Capacitor opposes the change like this, or in fact like this also. Why? Because it gets charged, Q equal to CV. Okay, and here V is changing. So every time it has to charge, discharge, charge, discharge. There is opposition. So capacitor tries to make the potential into the constant region, tries to reduce the ripple effect. So here answer is what? Capacitor. Okay. Then logic gates question. Okay. So here is 0, 0, 0, 0, 0, 0, 0, 0. Okay. Let's see what we can do. The first option we are going to take is 0 and 0. Okay. So let's assume that here is 0, here is also 0. Okay. This one is also 0 here. Right. So let's see what's happening over here. This is 0, this is 0. And this is not. So this will become 1. This will become 1. And this will also become 1. And this is end. So end will make 1 and 1, 1. But here not is there. So it will make it 0. So 0, 0's answer is coming 0. 0, 0's answer coming 0. 0, 0's answer coming 0. 0, 0 coming 1. That means this is not there. And 0, 0, 1. That means this is also not there. So answer will be either from this or this. Now next one is 0, 1. Let's see then. 0, 1. Okay. So here is 1. This one will be as it is. This 1 goes to naught, becomes 0. 1 and 0 goes to end. It will become 0. But then naught is there. That means 1. So 0, 1's answer is coming 1. 0, 1's answer is coming 1. 0, 1's answer is coming 0. That means this is also wrong. This is correct answer. This is correct. Okay, that's all. We have solved entire question paper, all 50 questions, along with the analysis. I hope it's going to help you when you're going to prepare for next year's NEET exam. Okay, thank you very much for watching. Bye-bye.